Okay, here we are again. John Fierhelm coming to you from Firehead-Q. And this time I'm going to get right into some Calypso stuff. Once again, I have been playing around with these NIST models that are available on the internet. And actually a few collections out there for what it's worth. They got these PMI-CTC definitions, PMI-FTC definitions, NIST PMI step files, which do have embedded PMI that Calypso is capable of reading. I've been playing with a few of these different models here. Right now, though, I'm going to take a quick look at this one, test model number 3. And it caught my eye because it's some sheet metal. It has some stuff coming in at an angle. And I recently wrote a guide for my team over in Malaysia on measuring sheet metal, and might be fun to apply some of the techniques to this part. I'm not going to do that tonight. Tonight, I'm just going to play with the PMI that's built in, and let's see what we can go ahead and do with that. So without further ado, let's load that CAD model. Working Calypso 2023 right now. And we're going to go to ASME Model 3 here. And boom, comes in, no problems. Turn on the datums and tolerances. Oh yeah, looking good. Let's go ahead and change those colors up. Whoops. No need. I usually heal if there's really errors that I can see nowadays. Most models come in with pretty good colors. Oh, well, colors are set by default. Just override. And let's take a look at got our datums. All of them in white. Got two true positions, some linear distances. Surface, I see. Surface, see. Okay, let's see what happens. Got our measurement plan. Of course, do anything with the additional settings. Ooh, tempted. ISO. Castings. Clamped steel parts. No. Anyways, so we'll just leave it at general tolerances. That's fine. And LSQ features, individual characteristics. Let's do this. Okay, and create. Oh, off we go. Creating that measurement plan. Oh, I should have showed you. I'll have to probably do that another video on that. Sorry, guys. About the default settings. Okay, so here's some datums that cannot be created. Primary datum could not be created. Let's see what the issue is with these datums. I think I already see the problem. In fact, I can almost guarantee that's a problem. Looks like it grabbed cylinders. Of course, this being a sheet metal part, you really don't want to do cylinders. Oh, and look at this. It's not a healed CAD model. So there are those lines on the side. It might need healing. Okay, so not bad. First off, let's just reduce the icon size. So there's a couple things that didn't come out. No datum. And that says cylinder 44. Let's go ahead and take a look at our drawing right there. So what's the issue? Well, I can see this datum F, not reference, justifies placing MCS at center of large hole on flange. Interesting. Okay. And DBC, DBC, DBC. There's C, AA, DBC. So D is this plane. And A is those two surfaces. B is this hole, and C is this hole. And perp to E. E is that plane. Angular to A. don't know. These all look reasonable. Real hard to check that. But, it would be more almost like it's perp to E though, so it's probably going to be good. Sorry, already getting into the manufacture of this thing. Well, anyways, let's see what Calypso did with that. So perp 1.1 is there. Perp 2.1. 1.1, 1.2, let's turn up. There it is. That's the one it doesn't like. Was there a feature E? Is that what we just didn't get with E? A is theoretical. Ooh. Oh, did it do a recall? It did a recall feature points. Hey, that's impressive. Okay, so these are planes, obviously. A1 and A2. Not bad, not bad. I'll give that to you, Calypso. Let me hit save real quick here. Oof. Ooh, lost display of my PMI. Back on. Okay, okay. Well, here, look at our datums first. So, for some reason, D did not create, and E did not create. Go here. D and E did not create. So D is, well, I mean, it's off in space. So yeah, I don't know what it was going to create. Let's come back to, sorry, our model, and D should have just been this plane. So what's this? Select already extracted. Plane 4. So plane 4 is D. Right? No way around it. It's D. What's the naming convention it wanted to use? It would have called it just D. Oof. I don't like that. I have to leave the feature name. But PMI, you now have a D. So that would fix these, right? So boom. Boom. It just didn't identify it properly. I don't know a way to tag that D onto that surface. Then anything that wanted D, see, there's the 820 thickness, which is probably material thickness, right? Yeah, nothing showing there, so. Have this surface? Well, I mean, obviously we would just use points, right? Let's find a space point here. And approximately opposite. No, that's not the right one. Well, I mean, it is, I guess. That's super dumb. Why would I do that? When it's the same material up here, why not just measure it here? It is, after all, sheet metal. All came from the same sheet. That'll do. Okay, so with a little assistance, the PMI worked pretty good. Not bad. We'll have to play with this again another day. I think there's a lot of stuff to cover when it comes to PMI. These NIST models look good, but not perfect. For example, really none of these cylinders should stay cylinders. We'd probably just go plan, advanced, convert cylinders to circles. Come up here. All those cylinders from circles, except that one, right? Or how many are in there? Oh well. 68. And then we would convert them to circles. Anyways, we'll catch you guys next time. I'll cover some details like that. Have a good one.